Now let's talk about proof by contraposition. So when you see contraposition, what you should be thinking is contrapositive. So your first step when you're doing proof by contraposition is to express the statement as for all x and d, if px, then qx. You need to have a conditional statement, okay? And then after that, what you're going to do is you're going to rewrite this statement using the contrapositive. So what would the contrapositive be for all x and d? If not qx, then not px. And then you're going to prove this new universal conditional statement right here. You're going to prove a contrapositive statement by a direct proof. Okay, so let's put this into practice. Let's look at an example here. Prove that for every integer n, if n squared is even, then n is even. So let's first rewrite this in our universal conditional statement for all integers n and z. If n squared is even, then n is even. So that was step one. It was pretty much already written in that format. I just added this universal quantifier here at the beginning. So now we want to write down the contrapositive of this statement. So what would the contrapositive of that statement, what would it be? For all n and z, if you flip them and then you negate them. So if n is not even, which you could say odd, then n squared is odd. So now we're going to prove this statement directly. And this is a nicer version because here I start off with information about n, and I'm going to conclude something about n squared. So let's write the proof now. What would the proof be? Starting out, I want to prove this directly. Suppose n is any odd integer. Okay. That would be your starting point. What's the conclusion I'm trying to get to? Conclusion I'm trying to get to is n squared is odd. That's what I'm trying to work up to. Well, by definition of odd, n equals 2 times k plus 1 for some integer k. Then, remember I underlined our conclusion that we need to show. It's about n squared, so let's compute n squared. Then n squared is 2k plus 1 squared. And then you're going to have to FOIL this out to get 4k squared plus 4k plus 1. What am I trying to say? I'm trying to show that this is odd. So I need to write this as 2 times something plus 1. And what goes in this blank right here? It's going to be 2k squared plus 2k. So I'm going to relabel that part that I've underlined in blue. I'm going to let t be 2k squared plus 2k. Then we have n squared equals 2t plus 1, where t is an integer. Therefore, n squared is odd. And that was the conclusion I was building up to there. So there we go. Our proof is complete. Our proof by contraposition is complete. Now I do want to make a note here. So note. If you compare this with contradiction, you're going to see that some of the same sequence of steps for a proof by contraposition can be used for a proof by contradiction. So if you were to go back to the original statement and prove it by contradiction, you'll see that some of the same steps that appear in that proof also appeared in the proof we just did.